Hello, I designed a VCA module, a VCA voltage controlled amplifier in this Kosmo format, which is like Eurorack from signal and power perspective, but 20 centimeter tall modules and these 1/4-inch quitter cable jacks. It's just easier to work with in DIY things because it's bigger and it's also nicer to look at. But VCA, what is VCA? Well, voltage controlled amplifier, the name implies what it does. So oscillators, like most people, scream eternally into the void, but we want to hear them only when we play a note. So VCA is controlled with a control voltage so that when I press key, it lets the sound through. But this, or these three, actually they're identical, are dual VCA, so there's two channels, two signal inputs and two control voltage inputs, but they are also basically a two-channel mixer and crossfader and banner, if you want to think it about like that. Potentiometer there just gives a control voltage and opens the signal so that you can have the signal go through. Then there is CV input, electrical hole, you put voltage there and you can use this potentiometer to attenuate it so it affects less. This goes from 0 to 10 volts, so if you put it to a middle point and have LFO signal that goes from -5 volts to +5 volts, or actually that would be too much. Anyway, so that when it sums with the signal here, you can get nice flow from 0 to full, or put like in a normal way envelope to have volume open when you want it to. I'm using these most as to sum signals from my oscillators. Like I have these oscillators that these oscillators have separate waveform outputs, square and saw and trongle, and I put the square and the saw wave to these channels, so I can have square wave going out or saw wave going out, or I can mix them to have more. There are more different waveforms, interesting waveforms. And this middle one here, the middle CV, is it affects both of the channels so that it's zoomed to the channel 1 normally, but as inverted to the channel 2, so when it rises, it turns on the channel 1, but attenuates the channel 2, so you can, like, you hopefully see from the oscilloscope what is happening there. But I have two oscillators. I like to put the other one to an octave higher and put it to another of these VCAs, and now we have much more lively waveform. And there's the third VCA that just sums the outputs, combined outputs of the first two VCAs, and that is also modulated a bit. That's nice. More lively sound. Of course, you could have post-processing, but why have much post-processing before if you can like pre-process the signal? Let's see the schematic for this. Yeah, okay, here's the schematic. It uses this AS33 VCA-60 chip that has 2 VCAs, so it was easy to make 2-channel VCA from here. Then the other chips, well, it's TL074, so basic op-amp. One IC chip has 4 op-amps, so it goes nicely because one of these channels needs 4. Here, the CV input, 3 different CVs are mixed here. One is that potentiometer that you control manually, then there's the attenuated CV input, and there's the combined CV input. This is a negative summing configuration, so here the signal is inverted. I mean inverted summing, not negative summing, but yeah. And this here is that we don't want to give too much negative voltage, control voltage to the chip, because it doesn't really do anything and too much of it breaks it. So here is a diode that clips the excess signal, but because the signal is inverted here, we clip the positive side of the signal. Here is just another inverting amplifier that, well, inverts the signal. And here the signal is, or here also you are driving the LED with the signal, so we can see how open the VCA is. And here the signal is with a resistor divider divided into 1/5, so we can have, because okay, this goes slightly over 10 volts with the amplifier, so this could actually be like 22K. So, but this can take in 2.5 volts, so it's not a problem, I think. And actually now I think this inverting amplifier could actually have the signal reduction here and not here, but I don't know. Here comes in the audio signal, one inverting amplifier with a resistor to the current input of the VCA chip, and here's the current output of it, and this configuration here transforms the output current into voltage. And this looks funny because usually inverting amplifier needs resistor here, but because this is current output and not voltage output, actually the resistor here works the same as if it would be here, but you need to control the current that goes in here, so you need to have a resistor here. I don't think about it too much, it just works. What else we have here? Okay, there's the second identical, actually not identical, previous version, because I have a couple of bugs here. Let's see if you can find the bugs. And here's the combined, or the dual, I don't know, the third CV input here. Signal goes as normal, polarization to the first chip, but inverted to the second, so it does what it does. And here's of course the mixer output that just takes the inputs of the both VCAs and sums them. You could say that maybe this should not sum them completely. I mean, if both signals are like maximum volume, it could clip here, so you could maybe sum them as slightly smaller than unity gain. But this worked for me, but I could maybe put a smaller resistor here. I need to test a bit, but that also depends on what kind of signal your oscillators give out, or maybe if you want to distort them, because distortion gives more frequencies, and more is more. Here's the power input. I like to put Schottky diodes here in series of the voltages. They lower the voltage a bit, but that doesn't usually matter. But if I manage to put the power input reversed, nothing burns, because these stop the current or voltage going the wrong way. And here are the input jacks, nothing funny there, except that when you put a jack to the input 1, it also goes to the input 2 if there is nothing plugged there, so you can put signal only to input 1, it goes also to input 2, and then use the middle CV and the channel separate outputs to, for example, band the signal to different sides if you are having a stereo setup. But that's about it. Thanks. I should have the schematics and probably the Gigart files, maybe even the Gerber files available. Of course, these are one generation older than the files because I had a couple of bugs there, but I'll probably order new PCBs and try them, but they should work. But use caution. Probably if you are ordering your own PCBs and building your stuff, you also have skills to debug, or this helps you to make your debugging skills better if I haven't made many mistakes. So it's like win-win. I do less work, you learn stuff. Yeah.